It should be recording now, so I'll post the recording after the lecture, or after this. So for lab 2, the first thing we'll be working with is matrix addition and subtraction. Let me see. I don't know. Anyway, I'll just present it like this. So with matrix addition and subtraction, both matrices have to be the same dimensions. So they have to have the same number of rows and columns. So in this example, you see there's A, B, C, D. The first matrix is A, B, C, D, and then the second matrix is F, G, H, I. And they're both 2 by 2 matrices. Oh, I see it. Okay. Present. Thank you, Alva. So yeah, so both these matrices have the same dimensions, so you can add them together. You just add each respective element. So you add the A and F together, you add B and G, C and H, D and I, D and J together. So for matrix multiplication and division, there's 2 different types of multiplication and division. So there's matrix and array. And they're both different kinds. So with matrix multiplication, it follows the standard matrix rules, which basically means it adds the rows and columns separately. So I'll show an example of that in the next slide. But in MATLAB, if you wanted to do matrix multiplication, you would just use the asterisk and slash as seen here. And if you want to do array operations, you would use dot, asterisk, and dot slash. So you make sure you add a period before the multiplication and division sign if you want to do array. And array operations are done element by element. So it's similar to adding and subtracting. It does each element separately. So I'll show examples of both of these. So this example shows matrix multiplication. As you can see, there's 2 different matrices, and the amount of elements in the row is the same as the number of elements in a column. So that's one of the conditions if you want to do matrix multiplication. If the number of elements are different for a row and column, then it won't be able to do it. It'll say the matrix dimensions are not consistent or they don't agree. You have to make sure if you have 3 elements in a row for the first matrix, then in the second matrix you have 3 elements in a column. And so what this does is so for matrix multiplication, it takes the first element, multiplies it with the first element in this column, and takes the second element in the row, multiplies it with the second element in the column, and then the third element in the row, multiply it with the third element in the column. And you see that over here, and it adds all of these together. That gives you the number for this. And then if you want to find out this, it's the same procedure, except it starts with the second row. So you just multiply the respective elements together, and then you add them. And for this, it takes the first row and the second column, and for this, it's the second row and second column. Does that make sense so far?
Yeah.
Okay, that's good. So I'll go into array operations, which is a little bit easier to understand. Oh yeah, so also if you want to do this in MATLAB, this is an example of how the code would be written in this box over here. So with array operations, you have to make sure the matrices are the same dimensions. And basically you just multiply the respective elements together. So in this you have 3 times 1, you take the 3 and 1, multiply it, 5 times 6 over here, 7 times 3 in this spot, and then 4 times 0, 9 times 2, 8 times 9. You see all of that here. It's similar to matrix addition and subtraction. And over here we also have the code if you wanted to do something like this in MATLAB, which you will do a lot, so it's a good practice to get used to it. So the next thing we'll talk about is, I guess, Boolean variables or logic. So this is basically when you have a statement and if there's 2 possible outcomes, it can come out as true and false. So when a statement is true, it'll give you a value of 1. And when a statement is false, it'll give you a value of 0. And this is mostly useful for comparing values. So a few examples of how that'll work in the next slide. So we'll go into relational operators, which basically is your greater than, less than, or equals to. And this is just a way of comparing 2 values or 2 variables to see if one variable is greater or less than another. This is similar to what you do in like standard math, for example. So each of these, they use these symbols here, the greater than, less than, and equal to. And the thing here, we have a double equal sign when you want to use equals. That means, and that's different than the single equals. So when you only have one equal, it assigns the variable, assigns a value to one variable. Then if you have 2 equals, it's going to check if 2 values are equal to each other. So over here we have a few examples. So if you were to type in 5 greater than 2 in MATLAB, it will return 1 because the statement is true since 5 is greater than 2. If you were to do 8 less than 5, it will return 0 because the statement is false. 8 is not less than 5. And that just goes back to the Boolean logic of variables. When it's true, it will return 1, and when it's false, it will return 0. So to make things, so then there's also a greater than or equal to and less than or equal to. So that's basically the same thing as the previous, except if the values are equal to each other, then it will be true as well. So in this example, we have 8 less than or equal to 8 will be 1 because they are equal to each other. But then here you have 8 less than or equal to 7 will be 0 since it's false. And this third example is also false because 8 is not greater than 9. Let me see if I can annotate. So if you have something like you have 8 is greater than 8, this will be false because 8 is not greater than 8. 8 is equal to 8. And if you had 8 is greater than or equal to 8, this would be true. So this would give you a 0, this would give you a 1. So the next thing we have is logical statements, which is basically and, or, and not. So there's 3 different types of logical statements you could use. And this can be used to combine conditionals. So if you have multiple conditions you want to test, you can use these and, or, and not to combine them together. So when you use the and statement or the and logical statement, you require that all statements would be true. in MATLAB just uses the and symbol, which is found over the 7. You have or for if you require one of the statements to be true. So when you use or and you have two conditions, only one of them has to be true for the statement to be true. So MATLAB uses the straight slash, which is it's found next to the left slash in the keyboard, and not returns the opposite result of what is expected. So if a statement is true and it would give you a 1, for example, when you use the not, it would give you a 0. I'll show an example of that. So if we have something like 8 is, you have this little tilde here is greater than 7, for example. So 8 greater than 7 is true, so normally this would equal 1. But because we have this not, let me see. How does this even else? Because you have this not sign in front, instead of being 1, it would be 0. So this just reverses the output that you would normally get. Huh. Okay, we were on this slide. So a few examples we have here is if we say 10 is greater than 3 and 10 is greater than 11, this would be false because only 10 is greater than 3 is true. 10 greater than 11 is false. So that would make this entire statement false because we have the and logical statement here. In this next example, we have 14 is greater than 8 or 4 is less than 2. And this statement would be true because 14 is greater than 8. So when we use or, only one of these statements has to be true for the entire statement to be true. And we see that since 14 is greater than 8, that would return 1 because the statement is true. In this last example, we have 14 is greater than 15 not, and that would be 1 because normally you would get 0 since 14 greater than 15 is false. But then since we have not, it reverses it, so it would make it 1 or true. Do these examples make sense so far?
Yes.
Okay, that's good. So with the MATLAB operator precedence, this is just basically the order of operations. So when you type arithmetic operations in MATLAB, it follows this order. So the main reason for showing this is just to see where the logical statements fit in this entire list. So you see that the logical not is at number 3, so it's pretty high up there. And then you have the last 3, which is just your less than, equal to, greater than, equal to. All of these would be at 7, and would be at 8, and then or would be number 9. And so the important thing is when you have these statements is to make sure you have the right order so that you're not doing them incorrectly. And so just to practice, we have a few examples here of how order of operations would work. So just take a few minutes and try solving some or all of these. I'll give you guys a few minutes to try these, and then I'll share the answers for these and explain how they work. It seems like some of you guys have finished, so I'll go over these examples. Or does someone want to share their answers for some of these problems? All right, I'll just go over the answers for these. Wait, can you guys hear me? Okay. So for the first example, we have not 5 plus, wow, my handwriting. 5 plus 2 is greater than 5. So this would be not 7 is greater than 5. So 7 greater than 5 would be 1. But then because there's this not sign, this would be 0. And for this next example, we have exponent of 0 is greater than or equal to 2 minus 1. So exponent of 0 would be equal to 1 because e to the 0 equals 1, or any exponent to 0 equals 1. This is going to be greater than equal to 1. And this is true because 1 is equal to 1. So this be true, and this would give you a 1. So these next few examples are a little bit complicated, but it's not that hard, I think. We have 10 over 2 equals 5. So this would be 5. So this would be not 5 equals 5. And this would, and we have, and cosine degrees of 90 is equal 1. So cosine of 90 is 0. So this would be 0 equals 1. So right now we have 5 equals 5. So this is true. So this is 1. But then this, we have this tilde. So this would make it 0. And then we have and 0 equals 1. So this is false. So this would give you a 0 as well. So both of these statements are 0. So it'll give you an answer of 0. But even if one of these answers was true, because this statement gives you a 0, the entire answer would be 0 either way. Actually, I could just leave that. So for the next example, it's basically the same problem, except this part of the statement is changed, and we have an or instead of an and. So we have or, let's see, cosine of 90 equals 0. Cosine of 90 is 0, so we have 0 equals 0. So let me see. So basically we have this, because this statement is true and it's 1, it goes to 0 because of the tilde. And then we have 0 equals 0. So this is true. So this statement is true. So this will give you a 1. So basically we have 0 or 1. And since we have this or, it means that as long as one statement is true, then the entire statement is true. So that means our answer will be 1 for this. And for the last example, let me just erase all of these first. So we have 100 divided by 2 is not equal to 50. So this would be 50 is not equal to 50. And we have or 10 divided by 2 is not equal. We have this not different. So we have not 5 is not equal to 50. So I'll start with this first one. So we have 50 is not equal to 50. So normally 50 is equal to 50. So this would be true. This would give you a 1 normally. But since we have not, So because 50 is equal to 50, 50 not equal to 50 is false. So this would be a 0. And then for this second statement, we have 5 is not equal to 50. So 5 is not equal to 50. So this statement is true. So this will give you a 1. But then we have this tilde in front. So now we're going to reverse it. So this will give you a 0. So what we're left with is 0 or 0. And both of these are 0, so the answer is 0. Do these examples make sense? Or at least how I explained them?
Doesn't equals mean?
What is it?
Why are there two equal signs? Why is there a double equal?
Oh yeah, so I explained that in the previous slide. I'll just go back. Someone has Discord going. Oh, anyway. So we have this double equals because it's going to check if two values are equal to each other. Normally in MATLAB, if you were to let me get annotate. So if you were to say like x equals, or not x, let's just say like 7 equals 8. This would actually, let's do x. So if we do 7 equals 8, it'll try to assign the value of 7 to 8. But then when we have, so if we have a double equals, it's going to check if 7 is equal to 8. Yeah, I have it explained over here. So that's basically the explanation. So the double equals is going to check if two values are equal to each other. All right, the next topic we're going to cover is flow control. Oh yeah, so for OR in MATLAB, it's the straight slash, which will look like this. It's next to the left, it's the capital version of the left slash. Oh, I mean, I could hear your Discord, so yeah, it's okay though, don't worry about it. Anyway, so for flow control, we have if else and switch case. And so for if else, it's basically going to check if the if statement is true, and it will run the code under the if statement. And if the if statement is not true, it will not run the code under. It will run the code under the else statement. And you could also have else if, which will act as an additional if statement if the first if statement is not met. We'll have examples of that later as well. Let's see. So I guess I have this example here. This is just what I thought of when I was writing the slides. But so the first statement is if you are studying for your classes. And if we assume that this statement is true, then we go into the code under the if statement, which is the statement right here. So the assumption is that you'll do well in your classes. But if this statement is false, then we move to the code under the else statement. So this is false, we move over to the else statement. And then we run the code under the else statement, which is this right here. And just to be sure, if it's true, you go over here. If it's false, you go over here. I have more examples, the next slide. Actually, we'll go over a switch case. The switch case is kind of similar to if else, but it also has, switch case is only used to check for equality when you have a few options. It's not commonly used. I usually never use switch case when I write code in MATLAB, so this is just to teach you that switch case exists. I don't know how often you'll be using this, but let's see. So yeah, you can technically just use if else statements anyway. So switch case is just it can be used for certain scenarios, but in most cases, you'll just be using if else because it covers a wider area of applications. So with switch case, the first thing we have is switch door. And we have 3 different cases. So these are basically just, so basically before this code is even run, we have to assign a value to door. So we could say door equals 1, 2, or 3. And basically, well, we had to choose one of these values before. So let's just say we say door equals 1. So we write this before, and then we type in all of this code. So what happens is since the switch door is going to check what value door is equal to. Since we have door equal to 1 in this case, it's going to go to case 1, and then it's going to run this line of code under here because it's under case 1. Or let's say we have door equals to 3. So when we have the switch door, it now checks the value of door. And since door is equal to 3 in this case, it's going to jump down to case 3 and run this line of code. Let's say, for example, we have door equals 5. So we don't have a case 5 here. So it would go into, so we'd go down to otherwise, which otherwise is just basically, it'll run. The otherwise option will always run if we have values that don't fit the first 3 cases. It's similar to the if else statements. So then since we don't have a case 5, so we drop down to otherwise, and then we run this code right here. Hopefully that made sense. And so I have an example here for you guys to try out. So basically, we went over this example of switch case, but you could also write this using if else statements. So for anyone that has, or you guys should have MATLAB open, and then you can try out this example. I'll give you guys a few minutes to try converting this switch case example to if else. And in case you guys are a little bit confused, it basically has the first case already done for you. So if you have if door equals 1, then you print f, and then you have this line of code here. So then basically you want to write in the code for case 2, case 3, and then the otherwise. So this is going to be case 2, this is case 3, and then this is otherwise. And basically under each of these, you're going to write in the code that you find in the switch else example. I'll give you a few minutes to try just typing this if else example out. And I have the answer in the next slide so you can compare afterwards. I think you could use print or fprint, but fprintf, but I guess Professor just has it as fprintf, so that's what I have here. I don't know, I think either one could work. You could just try it out and see which one works for you. I think since he has his reader, he has his /n here, so I think that might be why he uses fprintf, but I'm not sure. What's the difference? I don't know. I didn't even look into this. If you search on Google, you might be able to find the difference. I don't think it's that significant for this class though. Okay, I'm going to guess you guys have tried this example or just didn't do anything for this all this time, which is fine too. Anyway, so I'll have let me click on mouse. This is just a completed example. So you just have all the statements under each of these. I'll talk about the else if. So we have this if statement. So before this we had, let's say door equals, let's say 2. So we have if door equals 1. Since door isn't equal to 1, we move to the next else if statement. So since we have door equals 2, and that's true here, it'll go to this statement, it'll run this code here. And if we had door equals 3, so this else if statement would be false, it moves to the next else if statement. And then it runs whatever code is under that. So when you write these else if statements, it's going to check them in the order that you write them. So if you write the if statement, else if, it's going to check if this is true, then it's going to check if this is true, then it's going to check if this is true. So the important thing when you write else if statement is to write them in the order of importance, or basically which conditions are most important. You should write them on top because those will be run first, and then the less important conditions you could write on the bottom because they will be less likely to be run. All right, that's all I have for the slides. Are there any questions on anything that I've talked about for the past 40 minutes?
Are you going to post them on Canvas?
These slides should be posted on Canvas already. I see a few people are actually looking at them right now. Yeah, the slides are on Canvas, right? There's like 2 people that I can see that are looking at the slides right now. This M and H symbol, so I can actually show it on Canvas. Let me just go on settings, student view. It should be under lab 2. If you just click on lab 2 slides, it'll just pop up and then you can click on it and it'll bring you to lab 2. Let's see, all right, so I'll just go over the lab 2. As professor sent out in an email, we have the campus-wide license for MATLAB. So that means all of you guys can download MATLAB and use it on your own computer instead of using Citrix. And it's honestly a lot easier to just use MATLAB on your own computer. So you guys should read professor's emails and follow the instructions he has there. And that way you can get MATLAB on your own computer for free.
Yeah.
Yeah, it's a lot easier than using Citrix.
Yeah, it's not posted on Canvas.
Yeah, I think he sent out an announcement on Canvas. It should have been sent to all of your emails. So just check your emails if you didn't get the message.
Yeah, I was talking about the slide for lab 2.
Oh, the slides. Yeah, I just posted them on Canvas, so it doesn't get emailed to you guys, but you just have to check on Canvas and it'll be there.
Yeah, I
Usually,
clicked on Canvas, but it's not showing on my screen.
it's not showing on your screen. I don't know. We posted them on Tuesday, so it's usually posted one day before the labs. Yeah, I don't know. All right, so for now, I'll just go over this lab and basically the type of questions you'll be answering. So for the most part, the slides were created based on the lab activities that you'll be doing, so it should be pretty straightforward. But if you need any more guidance or help, you can also read through the lab handout, and that should make things more clear for you. So in this first question set, we're looking at basically, he's giving you basically two matrices, and he's asking you, can you add these matrices together? Yes or no, and explain why. In this first example, I have it done for you. I just say no because the first matrix is 1/5, the second matrix is 1/4. And since they're not the same dimensions, you can't add them together. And then he has a few more examples for you with A, B. And basically, you're just going to check these dimensions. So you see here it says A equals 1/4, and here it says B equals 4/1. So you're just checking if they're the same dimensions or not. If they are the same dimensions, you can add them together. If they're not the same dimensions, you can't add them together. And he gives you a few examples to try out and basically check if you can add them together or not. He goes over matrix and array operations here as well. He gives you this activity, write a MATLAB expression to perform these operations. So yeah, I think these will be matrix operations. And if it's not clear whether you have to use matrix or array, then you can check based on the dimensions. So since the dimensions are not equal, you can't do array operations. So these are going to be matrix operations. He has you complete this calculation by hand too, just to check the answer. I think that's optional, but you can try it out. And he has this example to square all even integers between 0 and 20. I think that's just creating a sequenced array between 0 and 20 and then squaring each element in that array. He has another matrix matrix multiplication here. He goes into Boolean variables, explains how they work. You have relational operations, and he explains so when you get 1 and 0. He has these little sliders so you can play with these if you want to. So he has this A greater than B, and then he has A and B here. So we can set A equal to 1, for example. And since 1 is greater than -2, it'll give you the answer is 1. And you could move this if you wanted to. So you can change B equal to 4, and then since B is greater than A, this answer is false. So you can just play around with these sliders to see where 0 and 1 would occur. And as he notes here, greater than operator will return 0 if the variables are equal to each other, because greater than is only true if the value is greater than. If it's equal to or less than, then it's false. So the same thing here with less than. And then he has this double equal sign for you to try out. So if you set these values equal to each other, it will be true and it'll give you 1. But if you change the values so they're not equal to each other, it'll give you 0. So all these sliders just give you an opportunity to try out different values and see how the answers would change just depending on that. And he gives you another activity. He wants you to predict the output of the code before running it and explain why. So basically here you would write down your prediction, and then here you would explain whether your prediction was right or wrong and why. At least that's what I'm guessing you would do. I don't know if this is already answered or not, but yeah, he has a few of these questions where he wants you to predict what the answer will be, and then you run it in MATLAB and you would check how you predicted it is right. So while you can just run these in MATLAB, I think being able to predict if the answer is right is important, since maybe on like a midterm, for example, you may not have access to MATLAB. So if he gives you a question like this on the midterm, then it would be important to be able to do this by hand. But for the labs, you can just use MATLAB, so it'll be a lot easier then. Let's see, logical statements. So here's something a little bit interesting. So at first he defines a variable, he defines matrix A, and then he defines another matrix, and he says it's equal to A is greater than or equal to 5. And so what that does is this is going to check every element in the matrix and see if it's greater than or equal to 5. And so whichever elements are greater than or equal to 5 will return 1, and any element that's less than 5 will give you a 0. So you can see from this matrix we have 2, 3, 9 for the first row, and then we have 2, 3, or we have 0, 0, and 1. And that's because 2 and 3 are both less than 5, so these are both false, it's 0. But then since 9 is greater than or equal to 5, it returns 1. And basically the same thing in the second row, since 6 is greater than 5, it'll give you a 1, 0, 0, because 1 and 0 are both less than 5. And then in this last row, since 5 is equal to 5, so this is greater than or equal to, so as long, even if both statements are true, or even if A is equal to 5, it will be true. So since 5 is equal to 5, this will be true, it'll give you a 1. And then you have 3 and 4, which are both false, so it returns 0. So this is just a way to check the entire matrix for a certain condition. It's pretty interesting, and he gives you an example here to try out. It's a little bit complicated, but if you think about it enough, you'll be able to figure it out. And then he goes over and, or, and not statements, as he mentioned in the slide, and he has these operators here, so you know exactly how you should be typing these in MATLAB if you want to test these conditions out. And he explains all the answers in this, so it's good to check them out if you're confused. He has the if-else statements, as I also talked about. And for question set 3, he wants you to use the slider bar to change the values of x to these values that he has, and then you should be explaining why the answer is the answer that it is. So let's say we set it to 50. In this case, y equals 0. That's because this code isn't run. But then if you set y equal to negative 40, then gives you y equals negative 76. So in this example, since the code is not run, since x is greater than 20, so x is 50, which is not less than 25. So it doesn't run anything here. So that's why y is equal to 0. But then when you have, let's say, a negative 40, it's going to run this code because x is less than 25. And so that's why you have this answer of y equals negative 76. Okay, I forgot to mention too, when you use if-else statements, you should, whenever you're done writing the if-else statement, you have to write end at the end of your statement. That basically ends the block of code that you've written. So you can add an else, which I also talked about. Consider the code snippet. Why wouldn't this work if it's odd or even? So he's basically asking you to explain why this code wouldn't work to display whether x is odd or even. Yeah, so the main answer is, since this conditional is outside the if statement, it won't work as it should. If you wanted this to work, properly, you would type in else and then type it in here. So instead of just having this conditional just randomly at the end of this block, you would have it inside the if else statement. Let's see, activity 4, recall multiples. Select different values of x. So he wants you to basically determine if x is a multiple of 6. And he tells you that x is also, he tells you that 6 is a multiple of 2 and 3. So I think what you would be doing is you would divide by, you would be checking if the values you get are whole numbers or fractions. And if you're getting fractions, then the statement is false and you won't have multiples of 6. But if you have whole numbers, then the statement is true and you have multiples of 6. And he goes over else if, which is basically just another if statement that runs in case the if statement is false. So else if statements always run before the else statement. So only if you have if statements and else if statements that are both false, then you run the else statement. And he basically has an example of how you would use else if and else. He goes over switch case. We went over this in the slides. He gives you the same example. And you can basically change the number of door, and that will change this output that you get. He only has door up to 3, but if you had, say, door equals 4, then you'll get this display if nothing happens. So that's it for the lab. And in the post lab, it's just you'll be solving some physics related problems apparently. I just looked over it yesterday. It seems like you'll be doing some graphing and solving equations. So it's a little bit different than the lab, but he has some links on the post lab, so it should give you an idea of where to start to find out how to do them. All right, so that's all I have. I think I'll put you guys in your breakout rooms and then you can start working on the labs together. Let me just stop share. So this lab session will go until 11:45. So last week what happened was Zoom just crashed on me, and that's why the meeting just ended at 10:30 for some reason. But if for some reason Zoom crashes again, I'll reopen the meeting. So if the meeting just randomly ends before 11:45, you guys can just come back and join here. I'll keep the lab sessions going until 11:45. So yeah, that's just want to clarify on that. All right, I'll put you guys in your breakout rooms. Let me see how this works. That's interesting. I don't think Professor created the breakout rooms. That's weird. I don't know how I'd put you all in your groups because